Motion in a plane, physical quantities, a scalar vector. A scalar, a quantity with magnitude only is called a scalar. It is specified completely by a single number along with proper unit. The rules for combining a scalars are the rules of ordinary algebra. It can be added, subtracted, multiplied, and divided just as the ordinary numbers. Example, mass, time, distance. For example, 1 kg plus 2 kg equals to 3 kg. 2 second plus 4 second equals to 6 second. 5 meter plus 2 meter, 7 meter. 7 meter. That is, mass is a scalar, so it is adding with simple algebraic method. Same case is for time and same case is for distance. Vector. A vector quantity is a quantity that has both a magnitude and a direction and obeys the triangle law of addition, or equivalently the parallelogram law of addition. So a vector is specified by giving its magnitude by a number and its direction. Example, displacement, velocity, acceleration and force etc. represents a vector quantity. Now representation of a vector. Symbol. By symbol we use bold letter and a arrowhead on the letter or by italic letter. This can be used to represent vector, and by diagram by a arrow, the arrowhead, and this represent tail, and this is a vector. Arrowhead shows the direction of vector and the length of arrow shows the magnitude of vector. Now for example, here O represents the tail of the vector and Q represents the head of the vector, which is equal to the B vector, or here it is a vector. Now we can write here, it can be written as OP vector. It represents that OP is a vector whose length is from O to P and direction is along O to P, and we have taken it as a vector, so we are writing it equal to a vector. Similarly, we are here writing OQ vector equals to B vector. Here arrowhead of arrow represent direction of vector, length of arrow equals to magnitude of vector. Now magnitude of vector A is written as mod A vector or simply A. Similarly, magnitude of OP vector, mod OP or OP. Since we have A vector equals to OP vector in above figure, hence mod of A vector equals to mod of OP or A equals to OP, etc. Position and displacement vector. Position vector, it locates the position of a particle at a given time with respect to origin. For example, we have drawn a Cartesian coordinate. Here is point O represents the origin, and consider a point is moving on this line. Then at any time t equals to point is particle is at P, and at any time t equals to t dash, particle is at P dash. Then OP vector represents from O to P. OP vector represents the position of particle P at time t. Similarly, OP dash vector represents the position of particle P dash particle at P dash, and OP vector and OP dash vector is position vector. Here OP vector equals to R vector, position vector of point P, that is position vector of particle at time t equals to t. Similarly, OP dash vector equals to R dash vector, position vector of point P dash, that is position vector of particle at time t equals to t dash. Now displacement vector, delta R vector. The maximum distance between the initial and final point and directed toward the final point is called displacement vector. Displacement vector equals to P dash vector del R dash or R dash del R vector equals to R dash minus R vector in terms of position vector. Here consider a point P is displaced from point P to P dash. Then at its initial position vector is OP vector, or it is written as R vector, and final position vector is a R dash vector. So this displacement, this is the shortest distance between P and P dash, and directed toward P dash represents a displacement vector, that is pp dash vector, which is equal to delta r vector, and we can write displacement vector as a pp dash vector delta r vector equals to r dash vector minus r vector. This can be shown with the help of tangent law of vector addition, which will learn we further. Now equality of vectors. Two vectors A and B are said to be equal if and only if they have the same magnitude and direction. If A vector equals to B vector, then 1 mode of A vector equals to mode of B vector, that is OP equals to QS as shown in this figure, and direction of A vector must be the equal to the direction of B vector. Here two vectors is shown, A vector and B vector, which is also represented by OP vector and QS vector. If they are equal, then their magnitude, that is length from O to P, that is OP, and length QS must be equal, and direction also must be, that is they should be parallel. Multiplication of vectors by real numbers. 1 multiplying a vector A vector with a positive number lambda gives a vector whose magnitude is changed by the factor lambda, but the direction is the same as that of A vector. For example, here A vector is represented by diagram, and when we multiply a number lambda, positive number, it becomes lambda A vector. Lambda times its length increases or decreases, it depends on the lambda, what is the value of lambda, and mode of lambda A vector will be lambda into A. If mode of lambda A vector is greater than mode of A vector, if lambda is greater than 1, and if mode of lambda A vector less than mode of A vector, then if 0 is less than lambda less than 1. This is the mathematical situation. Second, multiplication by a vector by a negative number gives a vector lambda A vector whose direction is opposite to the direction of A vector and whose magnitude is minus lambda times of mode A vector. Example, A vector, here A vector is represented, and this is minus A vector. Both have magnitude same, but the direction is opposite. It can be written as minus 1 into A vector. Here lambda equals to minus 1. So here again you see A vector, and if we multiplied 1 with minus of 1.5 A vector, then it will be in this direction, and lambda will be minus 1.5. 3. The factor lambda by which a vector is multiplied could be a scalar having its own physical dimension. Then the dimension of lambda A vector is the product of dimension of lambda and A vector. For example, here see, we are multiplying V vector with time. Here time is a scalar, and which comes out to be X vector. In dimensional analysis, if we write the dimension of velocity and dimension of time and multiplied it, we will get the dimension of displacement, that is distance. So it is also said that if any vector is multiplied with any number, a scalar or number, then the dimension also multiplied with that vector. Addition and subtraction of vector. Graphical method. Here two vector is shown, A vector and B vector. Now to add this graphically, for example, we have to add B vector on A vector, that is A plus B. We have to calculate A plus B, which will be equal to R vector, that is resultant vector. Here it is written as R is equal to A plus B. So to add it, first let's draw A vector, and then we have to add B vector. Then we put the tail of B vector on the head of A vector and draw a line from the tail of A vector to the B vector and give the arrow direction as toward the head of B vector. This will represent the resultant of A vector plus B vector. A vector and B vector, that is A plus B. Here this line represents A plus B. Similarly, we can add B vector. Similarly, we can find B plus A. In this case, first we draw B vector and then we add the A vector. We put the tail of A vector on the head of B vector. Here it is shown. We have drawn B vector and put the tail of A vector on the head of B vector. Now tail of from we draw a line from tail of B vector to the head of E vector, A vector, and this vector represents the resultant of B and A, that is B plus A, that is R equals to B plus A. This method is called head to tail method. This is also known as the triangle method of vector addition. Now vector addition is commutative, that is A plus B equals to B plus A. Here we have taken two vector, A vector and B vector. Now represent this with by addition rule. OP represents the A vector and PQ represents the B vector. Then we have put tail of B vector on the head of A vector. So this line will represent the resultant of R vector equals to A plus B vector. Similarly, we have here in this figure, we have put a tail of A vector on the head of B vector. So this line will represent the B plus A. This can be proved in the in triangle OPQ. We have OP vector plus PQ vector, OP vector plus PQ vector equals to OQ vector with the law of vector addition rules. This implies A vector plus B vector equals to OQ vector, equation 1. And in triangle ORQ, OS vector plus SQ vector is equals to OQ vector. This implies B vector plus A vector equals to OQ vector. So from 1 and 2 we have A plus B equals to B plus A proved. Also vector addition is associative, that is A plus B plus C is equal to A plus B plus C. That we have three vector is shown, A, B and C. Now here represented A vector, B vector, and this line represent the A plus B. Again, when we add C vector on this, then this represent A plus B plus C. So proof in triangle MOP, MP vector equals to MO vector plus OP vector. MP vector equals to MO vector plus OP vector. This imply MP vector equals to, now this imply MP vector equals to Mn vector, because MO vector equals to Mn vector plus NO vector plus OP vector. So we can write A plus B plus C, and in triangle MNP, MP vector equals to Mn vector plus NP vector. This implies MP vector equal to Mn plus NO plus OP, or A plus B plus C. So from 1 and 2 we get A plus B plus C equals to A plus B plus C proved. Null vector or zero vector. Here A vector is and this is minus A vector. If we add these two vectors, then we get null vector. Here it is shown R vector is equal to 0. We have put the head of a vector on tail of minus a vector on the head of a vector, so the it points at the tail of a vector, so there is no distance between tail of a and head of minus a, so it is represent r equals to 0 vector, that is a plus minus of a vector equals to a minus a equals to 0, and mode of 0 vector, that is null vector, equal to 0. Since the magnitude of null vector is 0, its direction cannot be specified. This is the uh, um, now properties of 0 vector. Now a vector plus 0 vector will be equal to a vector. Lambda into 0 vector will be equal to 0 vector. 0 into a vector will be equals to 0 vector. Subtraction of vector. We have a vector minus b vector, which can be written as a vector plus minus of b vector. Here a vector is and this is b vector, so minus b vector will be in this direction. Here it is shown a b, this represent a plus b. Now we can if reverse the direction of b vector, this will show minus b vector, so this line show r vector equals to r2 vector equal to a vector plus minus of b vector equals to a minus b. Proof. Parallelogram method of vector addition and subtraction. Let two vector a vector and b vector uh, joined with its tail. Now draw a parallelogram mm, with the help of these two vector, that is we draw a parallel line to the b vector and parallel line to the a vector. Parallel line to the a vector, this is shown, and parallel line to the vector, this is shown. And if we draw the diagonal, then diagonal will represent the vector a plus b or vector a minus b. For example, here we have drawn a parallelogram, so this represent a vector, and if we draw a parallel line here, this will be equal to b vector, so a vector plus b vector equal to this line, and this line represent resultant os vector, which is equal to r vector equals to a plus b. In this figure, b vector and a vector, and we draw a parallel line representing a vector. This line represent a vector if we draw arrow, and this line represent minus b vector because arrow direction is reversed, so it is represent minus b vector. Now a on the head of a we have put the tail of minus b, so from tail of a if we draw a line from tail of a to the head of minus b, this will represent the resultant of a plus minus b. So here we have r equals to a vector plus minus of b vector equals to a minus b vector. That is, one diagonal represent a plus b and other diagonal represent a minus b. This is the vector law of parallelogram. Again in this diagram, so this is a vector, this is b vector. Now if we represent it as b vector, and this if reverse the this direction of a vector, then will be minus v, which is shown here. Now on the head of b vector, tail of minus a is put, so this line represent r vector equals to b plus minus a equals to b minus a vector. Thus bigger diagonal shows the addition, other diagonal will show difference, that is a vector minus b vector or b vector minus b vector, depending upon arrow direction. Rain is falling vertically with a speed of 35 meters per second. Wind start blowing after some time with a speed of 12 meters per second in east to west direction. west direction. In which direction should a boy waiting at bus stop hold his umbrella? Here the situation is shown. The velocity of wind is shown in this direction, that is west direction, and velocity of rain in the south direction, and the resultant of this two will be in this direction. And so the magnitude of r vector is mod of r vector root under root vr square per vw square equal to 35 square 12 square meter per second equal to 37 meter per second. The direction theta that r makes with the vertical is given by tan theta equals to vw by vr equal to 12 by 30 by 0.343. Hence theta equal to tan inverse 0.343 equal to 90 degree. Therefore the boy should hold his umbrella in the vertical plane at an angle of about 90 degree with the vertical toward the east. Answer.